load the plot so you can know.
Yeah, maybe I think if I could do the light methodology of handling data sets and also the get rid of the influence of fertilizer. Maybe I hope I could get.
Yeah, it's like
some new
lots of things you have to do. So
step by step.
Step by step.
Anyway, so yeah, please.
I will create first like one variable here. So.
Yeah, we are doing it because when I applied for this methodology, I made a mistake because it's the predictor is selected randomly. So I thought if only I put the data set something like this order, so maybe the first portion is automatically used. I thought so, but it didn't. So I have to change the settings, maybe to here, data division and training here. This portion I have to change. Otherwise, I cannot get the right answer. So he will tell me how to divide selecting the predictors. Maybe this information could be useful for you to yeah. I thought if I choose a data set, separate the data set in advance, so automatically first 10 lines is selected and then calculate is going on, but it's said it's random or some data division is random.
Okay, so I just created like 2 data sets so we can do the analysis of. I have like the same thing.
Yes.
Here we have to get the predictors, the inputs, and the target. It will be the predicted variable.
Yeah.
Similar to what we are doing.
Yes.
Then
select that.
You have to check if they're like matrix or columns. You go next.
Yeah.
Here you have a training, validation, and testing. Yeah. The same thing. You calculate here the number of neurons. Next. You train the model. But if you say here, you check here the data division says divide rand. So we have to change this data division.
Random or divided, yeah.
See? And then
click here.
We have also to change the training algorithm. The one that William recommends in the book. You said like you have to check Bayesian regularization.
Bayesian regularization. Okay.
So check in the book, and it also says like what to do there. So Bayesian regularization. Check in your samples. You can plot fits, plot error histograms. I think that Juni had a question about the histograms, and this is like the distribution of the errors. So here they said that in theory the errors should be centered around 0. Good model. So the errors will be not skewed. You see this as a distribution that it should be here is 0, here is minus 54, here is plus something, and the whole idea of the models is like the errors should be around 0. you should not have like positive errors or negative errors, because that will be a problem in the
So in that
your
case,
model.
maybe as I said, detrending. If I apply for this methodology, the data it's kind of detrending, so it's plus or minus. So maybe it's zero.
Yeah.
Better. The concept is something like that.
Oh yes, yes.
Maybe.
That's when they said that use the anomalies, then the mean will be zero.
Yeah,
The anomaly.
Anomalies mean is zero.
Yeah.
So using a Bayesian methodology. Is this a Bayesian?
Not yet. No, I'm just like showing like the graphs that we generated before.
Yeah.
Uni asked me like what's the meaning of these graphs. So this graph shows the error. The errors of the model. It's important that the errors are in the center.
In the center.
If the errors are like located here or in one of the sides, it's not good. Good. Then of course this one, so you can change all these things.
Also, sorry, iteration. I don't understand iteration. Iteration. What's this meaning? Iteration.
An iteration is like a recursive algorithm.
8 iteration. This number is changing. What's the meaning?
It has to advance. It's like because you don't get the answer in one step.
One step.
So in the iteration.
So 8 means 8 steps.
Imagine that the true value equals 4. Model value you start with a guess. Let's say like it could be 1. But you see the difference between, let's call this t and this call m. If you say like t minus m equals 3, it's not good. No? So you have to go to 4. The true is 4, but your model is 1. So in the next step, you have to minimize this one. You have to minimize t minus m. So then the model will have to adjust this, and then in the second step, in the iteration, let's call it iteration, so we will know. Iteration. Right, 2. This will be iteration 1. M, it's 2.5. And then the model said, okay, then t minus m equals 1.5. Definitely is not good enough. Then in the next iteration, then the model does the regression. Then you get the iteration 3. T minus m, imagine that here m now is like, oh no. This is not good enough. Let's go and predict 5. In this case, t minus m will be minus 1. But the absolute value, let's try to use it in absolute values, then this will be 1. That is much closer than the first. So in three steps, now you are like in an error. This is the error. Imagine that this will be the error. And then in iteration 4, then say, okay, between 5, my error was 1. 2.5, my error is 1.5. So let's try to go iteration 4, for example, then t minus m, absolute value, and then in this case m equals 4.5, and then this one will be 0.5. At one point you will stop, and then say like, okay, stop if this error is closer, is 4.1, for example, and then the model stop the iteration. And then in iteration 4, say, okay, the answer is 4.4, 4.5.
So absolute value of t minus m equals 0 is preferable. I mean,
0 is preferable, yeah. So this is too big, this is too big. So see, we're getting closer to 0.
This software I tried to make it 0.
Yeah.
as fast as they could.
Exactly. So it
So
requires these iterations.
So if they have the 8 iteration means trying to make it 0, almost nearly close to 0, 8 trial was conducted.
It has to try
tried 8 times.
many times.
Many times.
Sometimes could be 20,
But
100.
they say 13 iteration. In this case,
in your
they
model,
tried.
if you remember, your model was like 6 iterations, 9 iterations.
Yes,
In this case, it arrived to that error in 30.
But it's not equal 0, but almost 0. Almost.
Yeah, getting to 0 is
getting to 0.
complicated.
Yeah,
It has to be the same. So.
13 trials was conducted.
Yeah.
That's suggested.
Yeah, plus remember that you have like a cure. So this is the true cure. The model cure will be, in order to have 0, it will have to be over this cure. So. But you have like also errors. So imagine that this will be, this is the cure, and imagine that this one will have like excess. So this will be a model with a 0 error, but that's impossible. So if you get a model that still like has like an X here, 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 then you see that these the errors, these errors compensate with these errors, and overall the error is close to 0 point something. That you set in the computer has a threshold for the error, so it's like a stop when the error is, for example, 0.1. So you have to get like closer to the real line, but of course getting the same values is almost impossible. Because you have like so many points. And the observations usually are fitted to noise. They have like instrumental errors, reading errors, measurement errors. Somebody said that it's 5, but the value was like 4.8. They like to approximate, but it was like not the real value. So there are like many different sources of uncertainty. So okay, so that's what happened with the iterations. Then the performance, yeah, this is everything is similar. It has to go close to 0, and then the all this. Then you can create additional tests. You go here, but what I wanted to show you here is that actually you have an option. Probably here you just like click finish when you, but you can click simple script.
Simple script. And the script comes up.
And well, remember that we were like dealing with this. So this is like the. Actually, all what we did is in this script, the computer is doing like all these steps. We started doing like the graphical user interface because it's like friendly, it's easier to understand. But sometimes you just need to, if you run this script and you save it with one name, then this will do exactly what we did before.
Modify. We have to modify.
So here you have to change like some things, no? For example, you change the number of the hidden neurons. Here is hidden layer size.
Hidden layer size.
Yeah, so if you want to change the number of neurons, the default that we use in the program here is 10, but you can change it here in the code and then you run it. Here they select net divided parameter 70, 15, 15. Then how to train the network, how to test it, and then the plots. So, but we need to change like some.
Yes.
This is we need to change some of the parameters. See? So what?
And for example, my data is starting from first, maybe first, first 10 or 20, I think.
So then what we do is like there are like some options in the toolbox, of course. Toolbox, product, help, should be this one. Yeah, okay. So you go here to the neural network toolbox, and they will select all the parameters that you can change. So if you see here, they say like functional reference, they say like all the functions that they are available here. So you have like performance functions, plotting functions, processing functions, topology, and lots of things. But for example, one that we need to change is the performance.
Performance. Right.
Yeah. So the default is MSE, but you can change it to the mean absolute error or to the sum of squared errors. In general, what you are using by default, MSE is fine. But you need that. But you need to know that you can change these parameters. Good. So now we also have to change the training function. So
training function.
So here it says like training function. Then you click it there, and here it says all the training functions that you can use. The one that we are using by default is train LM. See?
Train LM.
Yeah, it's the Levenberg-Marquardt backpropagation. That's the default one that we are using. This one.
Train LM.
Yeah, that's the default one.
This is the train LM is the default name.
Yeah.
Yeah.
The one that we would like to use now, and the William Sensei suggests, is train BR.
Train BR.
That is Bayesian regulation backpropagation.
Bayesian regulation.
So here,
Bayesian regulation backpropagation.
Yeah.
Bayesian regulation backpropagation. Yes.
so then here, if you click here, it says all the description of the function, how you can change it. So instead of using the train, you use train BR and these inputs.
Yeah, this one.
Yeah, this is like the command line that you need to use. And then it will train using backpropagation. It depends on the version of MATLAB that you have installed, but these are all the options that you can change. So if, for example, after you create a network, you type net.trainParam epochs. This is the number of iterations that the maximum number of iterations that it will train. So in our case, it went to 13. In your case, it was like 6 or 8, but it can go up to 100. The performance goal, if you see, is to go to 0, but there is like an adjustment of what's like the performance gradient. Once the gradient is not improving here, the sensitivity value, then you will stop training. So these are like the things that you have to use. So one way of setting this is, for example, you say like set nate.train function to train BR. And then you can see here like some examples. So what we can do is like we have like our script here, and then we can copy, for example, this one.
Yeah, train N.
Here you come here, you have net. After you create the net here, then you can change the parameters of net.
Train PCI. Train net.
And then you just change the train function. Before we have where was it? Where is our help? Here, see? And then and also another version, another way of doing it is like you can set the training function here directly when you have the network. So if you have like this syntax, it says like you create a network that is net equals new feed forward network. Then this is the input, this is the output, this is the number of hidden layers of neurons in the hidden layer, and then you leave a blank, and then the next space you can set it to train VR. So if we use a new FF function, you can set that parameter to train VR. In this case, we are using a fitnet, but where the only input of this is the hidden layer size. Okay, so that's important that you know how to change the function. This basically is the command. The other way that the other thing that we need to change is how you divide the percentage here. So I will load a code that I have, and then I will copy it because it has like some steps. But the idea will be let's change it. I have it here. I'll have to go to Dropbox. Let's see if I have the code here, so that I have it in the other computer. So I'm trying to, I need to extract it. Okay, so let's do it then the normal way. So there is like also a division of the parameters here. When you go to the neural networks, there are like different functions, and some of them are like just how to divide the parameters. So divide performance. Let me try to find it. transfer with
And dividing the data. I mean, if there's a certain number of data, divided in two means 50 and 50.
yes, but we that divides like a percentage, and then what we need to create is like an interval.
The interval.
I don't know if in this version it has it. Let's see. Distance, set parameters. Divide ind this one. Good. Yeah. So you remember what the performance, the divide function that we use in the program is divide rand, R, A, and D, no? Because it divides randomly. But what you need here is just to divide the targets into free sets using some indexes. You need to know specifically to say like, okay, this one is like 1960 to 1970. This one is 1971 to 1980, and so on. And then you say like, use the training, the validation, and the testing according with the units that you have here. So if you see, for example, what you have here, you said like number of targets to divide up. So it's like the number of samples, and then you said the train interval, like the index, says like train ind is like the training indexes, then val ind is the validation indices, and the test ind is the testing indices. And then it returns like free values, the same thing, validate the indexes unchanged, the test indices unchanged. But then, for example, what you have here is that you said 2001 to 2500, for example, use it for training, for validation, and the 2501 to the 3000 use it for testing.
And from the beginning, from the column, you mean the data is
yeah, it's
this low, it's from 1 to 2000 something values.
Yeah, so that's like how you divide. There is also divide. I think that there was like another one, another version that is divide int. And this probably will help you too, because you can also divide the targets into free sets using the indices. So this is like a normal, a regular one that says like, okay, you divide the numbers of targets into 0.6, 0.2, and 0.2. So that's like similar to what we are doing. See, you divide 0.6, 0.2, and 0.2. So
60% and 20%.
20% and 20%. So there are like these different functions that you have to know how to use to divide the data. And if you see, you can use all these options. So this is the one that we are using by default, divide the data randomly. Then this also divide the block, that it divides it in continuous blocks. And separates the targets into free sets of training, validation, and testing. And then so that's the one that you have to check, to try to these are like the automated data division. So that's like the one that you have to check. So first you check this one, that is the divide, the net divide function. You have to change it. You have to see which one you like, what's the one that you need to use, if divide int or divide int. But these are the options that you can change. And then if you just set to this one, then this is the syntax that you can copy into your script. And after you set the network, of course you can create all these things. So here you are saying like divide the network using a train indexes, a validation index, and a test index, and you can set those things instead of selecting these percentages. And then what you do is, instead of here, when you train the network and when you test the network, instead of writing like the inputs or the targets, you can use a block that was divided in this division. So you can divide it in many different ways. Or what you can do also is, at the beginning of your script, for example, you can divide it by decades. So for example, divide in 4 blocks. And then you can say, for example, that the first block, that you can call it A, it will be the information from the predictors from for example 1, all the rows, but from year 1 to I don't know, you have like 40 points, for imagine that it will be until the 10th. Then the B one, it will be, the B will be predictors from this one, from the 11 to the 20, and so on. A, B, C, D, and then you can, etc. And then when you are like training the network, here the inputs, for example, you can say my inputs will be A, and my targets will be A target. You also divide for the predictants, for example, A targets, like that will be predictant from actually it's 1 to 10, and then you just can change it and then now you know the syntax. So you just like said, okay, I need a network that uses this part and this part, and that's it. And then here you use, okay, it's trained, now to test it. So now to test the network, then you also can get like the outputs in the independent set, that it could be the decade C or the decade D, and then you will get the values only of the decade D. And then at the end you concatenate the results, and then you know that you will get the outputs from D. This will be outputs from D, for example, and at the end you can get like the final. After doing this 4 times for each decade, you can say like the final output is outputs from A, outputs from B, outputs from C, and outputs from D. and then this will be your final answer of cross-validated values. After doing this like for each decade or for 4 times as you did before. So you can write the script and it's like really flexible. Just change these parameters. You can delete them and just set the things that you want to validate here.
So we could just put the left behind this one, but instead of delete this, but type this and kind of sentence, something like that. You delete 1 7 something like that. 70% or 20% here, just now. You delete it. This one. So just to do this sign here. So that you know. Thank you. Yeah. Okay. So instead of this, put here.
Yeah. So this is a comment. It will not be done.
Yes. So these commands are using the first 10.
First 10
as a first 10 predictors.
This is an example, and you can just like keep like adapting it to your code. The idea is that you have to use this parameter to divide it, learn how to do it, how to use it. So check divide int, and then also check how to set these parameters. So if you use train VR, then you can set the validation in 0. You don't need validation data with this kind of neural network. One of the advantages of the Bayesian regularization is that you can use an extended use the data more efficiently.
So in that case, I don't have to rearrange the data sets, just using the one types of data, and then automatically select the points.
Don't rearrange the data. Just rearrange the data here in this part.
Arranging data is here. In this part.
You arrange it here. You don't have to create the data.
You have to do that.
It's easier because you can rearrange it here. For example, actually what happens is like what would you need is like actually it will be more interesting because the idea is that you will need 3 decades to train and 1 to validate. Yes.
3 decades.
Yeah. So imagine that we have like A, B targets already created, and C targets, and D and E targets. So you need to use not only A here, you need to use a set of that is it should be A, B, C, and here it will be A, B targets, and then C targets. Yeah, so this is like this is like, okay, train the network with these 3 decades. So there are like 30 points. And then you only validate with D, and that makes sense. So we are using all the data, A, B, C, and then D. So this will be 1960, 1970, 1980, for example, and this will be 1990. Then if you want to do it again, then you use a similar structure, but then instead of, for example, now you need to change it here to C, and then you put D here, and here D instead of C, and then you have the answer for D, and this will be the outputs of C. So you just do this like 4 times, and then you have like the answer. So you just have to copy the same code like 4 times. But it's really easy because then here you just like have to change like they say okay this and this A B D. Then in the next one you need the outputs from B, for example. So B, so then you try to get the B here, and then here you can use C instead, and here and then now you just like got D, C, and B, and you do the same for A.
So, for example, maybe I try to do that. Very very useful information. But as for the doctor, Yun-Hee-san, outliers can be added here, if possible. My idea.
The outlier?
Outliers comes. So the outlier is kind of setting outliers A or C, and then calculate.
Oh, for Uni?
For Uni.
Yeah, she will cross-validate. Yeah, in general, we always cross-validate the models. Linear regression or neural network, and this is like a cross-validation. What we are doing here is like training with 3, validating with the remaining 1. And then you just like shuffle these ones. So instead of having A, B, and C, I'm validating with D.
In this sense, the trains are videos A and C and D. Train videos.
Yeah.
And validation is a B, for example.
And the validation that is here.
Validation.
See?
Is a B name here.
Here is B.
So
but that's testing. In this case, we are not validating. There will be validation if you use train VR. Depends on the MATLAB that you have. You can use this function here directly. If you use this one, it will train VR. It will be the same thing as doing this one here.
Bayesian methodology.
Train VR.
Bayesian methodology.
Yeah.
What's the difference between Bayesian methods and
Levenberg-Marquardt?
Why the professor proposed that change to Bayesian method?
Yes, because the Levenberg-Marquardt is you have the data set and you divide it in training, val, and test. This methodology, this is for the Levenberg-Marquardt, and that's how it usually is. But the Bayesian can have like can use up to here to train, and then you test. So one of the importance is that you can use like more data points. For example, in his case, you have to always have like these points for validation, because this model needs validation data. This one needs validation. Train VR doesn't need validation data. So here, for example, in his case, we have to use, I don't know, 20, 10, 10. Now, here you can have like a model that uses 30 points for training, and you keep validating with 10. In theory, this Bayesian regularization will use the data set more efficiently, the training set. It could use the whole points, or it could use a little bit less, but you are not restricted to divide it and create like these hard bounds to separate them. So you only need to separate the test, but the train, you don't need a validation in this case.
So the number of data is limited. So we don't spend resources for variations.
Yeah.
So skip the variations.
Imagine that the way that this training algorithm works, it uses the information of the previous step to also to update the values. So it's almost like it optimizes the parameters with all this data. in the previous version you need a training and a validation, and if they are the same they will stop. If not, they will. If they are the same, that's like desirable. If the validation error is going up or is like completely different than the training, then they will say, okay, that's not desirable, and we have to stop it. If they keep the same, they can keep improving. But in this case, you can use like the data more efficiently, and that's like why we and we like it. So it's just a little thing is that you change from train RM to train VR, and that's like the really simple thing. So, but in the train LM, so you have to here this one. The train LM is the default one. If you add like train VR, then it will work. It depends on you have to check the version of your neural network toolbox, because as I showed before, you can have train VR and it could work, or this train, and then you have to add an option here that says train VR as an algorithm, as a defined function, as a training function produced here. So so it depends on the toolbox. So you please verify the version in the MATLAB that you have, and but then that's like exactly what we like to do, because you needed to do this Bayesian regularization. You can use now more efficiently the data, and if you divide the parameters using divide int here, then it's easier. So another way of doing this is like, if you see here how it works in this divide int, you have the data and it will divide it in three intervals. Yeah. So yeah, the important thing is that you said that you don't want to you change the parameter from divide rand to divide int or to divide block, but do not use divide rand. So please check how to use it more efficiently, because they randomly, if for example here we have like divide rand, the divide rand will create this, but when you are like cross validating, you don't know if you will pick values from here.
On which portion?
Yeah, it will use a percentage for testing, but not necessarily will be a percentage in the last part. So when you use divide rand, then even if you shuffle the decades, you could be using data that you thought that was in the testing in the last part of the last 10 years of data. That could be used for training, for example, because you just divide it randomly. So randomly, it's just like I will pick upon here, upon here, upon here, upon here, just. And then if that's like, this is pick like 30% for validation. So the validation could be anywhere. If you divide it by decades, you know that the training part is the beginning, the validation is the middle, and the last one is the testing. For example, you control the model. You know what you're doing. In the random, if you divide it randomly, you don't know which points are being used for validation. And in the case that you have like only like 40 points, then you need to cross validate, and that's like when it's handy to know the division of the data, because you need to cross validate. If you don't need to cross validate, using divide rand is fine. And so probably you need to have like thousands of data points. Maybe you don't need to cross validate. Maybe it's fine if you use the divide rand. But if you have like if you are going to cross validate, it's always recommended divide int or divide int gives you like the control. You are controlling what the program is doing. In the randomly, the program does it fix by itself. So it's important for you to know those things.
Okay. So instead of using divide land, instead of using divide land, but maybe divide ing function. Divide ing instead of divide land, but divide ing.
Yeah, there divide.
ing. Okay. So will you please send me this script to mail me?
The help?
No, not help. But
Oh, the script.
Script, yeah.
Oh, sure, but probably will not work.
Yeah, it's okay.
You will not.
I try to make by myself.
Okay.
And try and error and sometime this week and next week, and then I'll ask you.
Okay.
Okay. This portion.
Yes.
Please send it to me.
Sure.
Thank you very much.
Oh, very well.
Very well.これをオフスイッチオフね。